Our second biotic factor that we are going to measure is how to estimate the abundance of organisms. Why is it important to know the abundance of organisms? That helps us when we're making decisions in an ecosystem that would affect the entire population. If we make a decision based on an estimate that's been too high, like if we think there are more organisms than there really are, then that decision can lead to extinction of a species. If we have an estimate that is too low, and we do not take action, or we preserve something that is there, we might unnecessarily hurt people that depend on those animals or those resources. Now, it doesn't make sense for us to go out in an ecosystem and count every single organism. Not only do we have enough time, but that is impossible. So what we do is we take a sample, and then from that we can extrapolate how many organisms there are and get a pretty good estimation. So the question is, well, how do we do that? There are several ways. One way, if it's a stationary organism like trees, grass, plants that aren't going to just uproot and move to another area, we can sample what is called a quadrant. If it's a mobile, and I know that you can't read this, but if it's a mobile organism, an animal, we use what is called capture, mark, release, and recapture, and that's where we tag and count. So what a quadrant is, it's a frame, and you'll have a specific size. It can be large or small depending on what type of organism you're looking at. Usually it's about 1/4 of a square meter, and you're just going to count the organisms within that quadrant. There's several ways that we could place the quadrant, using number tables to find random areas to place. If you have an ecosystem that is stratified, which means it has areas that are different, like the first example, it's separated by a road, so you've got two different habitats on either side, and here between the fork and the road. Or if you have two different types of ecosystems, because here I have prairie that's surrounded by forest. So I need to make sure that it's randomized within each section, but that I have the same number, or at least a pretty good spread of quadrants in each section. Now, if another way to place the quadrants is to use a line, a transect line. So this would go the length of the ecosystem, and instead of having a quadrant, you're just going to go straight along that rope and measure every single organism. Now once again, this is for stationary. An interrupted belt transect uses a belt, so this would be similar to having quadrants across a line, and you measure on either side of the rope, but it would be interrupted so that there are space in between each set of quadrants. Now, depending on the organisms, sometimes we'll count individuals. One example are barnacles. Those are the little creatures that attach themselves to the sides of piers or the backs of whales. But certain plants, it doesn't make sense to go and count every single blade of grass or bloom, so we can do a percent cover. Another way we can measure it is population density, so find the mean number of individuals per quadrant. Percent frequency, of all of your quadrants, what percentage did that species exist? Because you might have your species exist in one quadrant but not in another. Alright, for our mobile organisms, we use the capture, mark, release, and recapture. We want to capture as many individuals as you can using some sort of netting or trapping without harming the organism. You want to mark them, but you don't want to make them more visible to their predators, or that can affect your results. Then you would release them back into their habitat and recapture them the same way that you did in step one, whether it's netting or trapping, and then you'll count how many marked and unmarked you have. If you don't have at least 10% of the individuals you catch that are marked, then you need to go out and do it again, or else your results will be skewed. So here's a few examples of tagging. You've got putting the almost like a bracelet around the bird. Here you've got your butterfly wing, and here on your fish. All right, so once we have captured, marked, released, and recaptured, we can plug those numbers into a formula to get an estimated population size. So in this formula, N1 is how many animals you caught the first time that you marked and then released back into the ecosystem. N2 is the total number of animals that were captured in the second sample. So that includes both tagged and untagged. And then M2 is how many were marked in that second capture. Capital N is your total population once you have multiplied and divided by your other values. We'll do some examples of this in class so you have some practice with this formula.